So I want you to try something right now, wherever you are listening to this, whether you're sitting in your living room or walking down the street or, just on your commute.
Just take a look around.
Yeah, exactly. Take a second and just look at the empty space around you, like the space between your screen and your face, or the space between you and the wall.
Right.
And now, let me ask you a question. Is that space actually empty?
It's a great question.
Or is there something there, something invisible that's just kind of connecting it all together? Welcome to today's deep dive. We are thrilled to have you with us because today we're going to tackle that exact question.
We really are.
We're exploring this totally fascinating concept from our sources titled Aether, the idea of the subtle medium. And the mission for this deep dive is to trace one of humanity's oldest, most stubborn intuitions.
That gut feeling we all have.
Right, that gut feeling that space is filled with something. And we want to track how that single idea evolved from ancient philosophy all the way up to modern quantum physics.
It's a really remarkable journey because when you examine the history of this concept, you realize pretty quickly that humans have just never been entirely comfortable with the idea of pure, absolute nothingness.
No, we hate it. We really do.
We do. We are constantly trying to map these invisible frameworks that support our visible reality. And this text shows how the idea of a subtle medium perfectly illustrates how human curiosity operates at a fundamental level. We've just always sensed a deeper structure beneath the void.
Okay, so let's unpack this. If we go all the way back to ancient Greek philosophy, they looked up at the night sky and believed there had to be this mysterious fifth element.
The ether.
The ether, right. And what's crucial here is that they didn't just invent this out of thin air for, poetic reasons.
No, they actually had a mechanical problem to solve.
Exactly. They looked around and saw that earthly elements, earth, water, air, fire, they were prone to friction and decay. And any linear motion down here eventually just stops. But then they look up at the planets and stars.
And they're moving in perfect, eternal circles.
Right. So they needed a reason for that.
The Greeks needed a physical justification for that eternal motion. The heavens were considered this entirely different realm, far purer and more refined than the chaotic, friction-filled Earth.
So they couldn't just be moving through regular air.
Exactly, because air creates drag. And it couldn't be fire because fire consumes itself. So ether was proposed as this frictionless substance that filled the cosmos beyond the earthly sphere.
It was literally the medium the stars moved through.
Yes, it wasn't just empty space. It was the physical scaffolding of the night sky that allowed for perpetual, perfect motion.
And this is where I think it gets super interesting. If we look beyond the Mediterranean, we see this wasn't an isolated theory at all.
Not at all.
You travel eastward to Indian philosophical traditions, and you run into a highly sophisticated, completely parallel concept called Akasha.
Right.
And Akasha is deeply interesting because it's often poorly translated as just space or emptiness.
Right.
But in systems like the Nyaya or Vaisheshika schools of thought, Akasha is far more active than just a mere void.
Yeah, reducing Akasha to empty space completely misses the mechanical role it plays in those philosophies.
Tell them why.
Well, it's recognized as a subtle, pervasive field that specifically serves as the medium for sound and vibration.
Right.
In these traditions, you cannot have vibration without a medium to carry it. Akasha is the dimension that allows form and frequency to exist in the first place.
That's such a cool way to think about it.
It really is. Think of it less as an empty box where events happen and more as the tensioned canvas that actually allows the painting to be painted. Without Akasha, there is no spatial extension and therefore no physical reality.
And we see another distinct approach in Chinese philosophy, right, with the concept of qi.
Yes, absolutely.
Now, a lot of people listening might be familiar with qi in the context of traditional medicine or martial arts as a life force.
Sure.
But in traditional cosmology, particularly in Neo-Confucianism, qi is the fundamental continuous substance of the universe.
It's a vital field of energy.
Right? Flowing through nature. It condenses to form solid matter, and then it disperses to form what we perceive as the empty sky. It's an active, flowing, connective medium.
And when we synthesize these ideas, so the Greek ether, the Indian Akasha, the Chinese qi, this really profound global parallel emerges.
That's right.
It is. Across vastly different civilizations and intellectual traditions, humanity shared the exact same foundational intuition. They intuited that reality could not possibly be composed only of isolated, solid objects separated by absolute nothingness.
They sensed these invisible fields and continuous flows.
Exactly. They felt that the seemingly empty space around them was actually brimming with hidden dynamics and latent energy.
So for centuries, this invisible scaffolding served as a beautiful philosophical safety blanket. It made sense of the world. Well, but, humans, we don't just settle for philosophy indefinitely.
No, eventually we want to measure things.
Right. Eventually we try to put a ruler to it.
Yeah.
So here's where it gets really interesting. We move forward to the 19th century.
The era of classical physics.
Yes. Physicists decide it is time to stop philosophizing about this subtle medium and start proving it actually exists. Enter the luminiferous ether.
This represents the great pivot. We're moving from metaphysics to rigorous physical science. And honestly, we have to give the 19th century physicists their due here.
Oh, totally. They weren't just guessing.
Their reasoning was incredibly sound based on the physics of that era. The urgency to find this ether really skyrocketed after James Clerk Maxwell formulated his equations for electromagnetism in the 1860s.
Right, because Maxwell's equations were a massive triumph. They unified electricity and magnetism, and they proved that light itself is an electromagnetic wave.
Which was a huge breakthrough.
Huge. But it also created a massive conceptual headache. Because in classical physics, a wave isn't a thing. It's an action.
Right, it's a disturbance traveling through a medium.
Exactly. We all know sound waves require air or water to propagate. You can't have the wave and nothing. So when Maxwell proved light was a wave, the immediate, undeniable conclusion was that light needed a medium to wave through.
If we connect this to the bigger picture of 19th century physics, the existence of the ether wasn't just a hypothesis, it was a mathematical necessity. They literally couldn't conceive of a wave propagating through an absolute void.
It broke all their rules.
It defied all known mechanics. So they deduced the existence of the luminiferous ether, the light-bearing ether, this universal substance filling all of space. But here is where the mechanical properties required of this ether become incredibly problematic.
And frankly, a bit absurd.
Very absurd.
It's what I like to call the ultimate space jelly paradox. Because think about it, light travels so incredibly fast, right? So the medium carrying it would have to be unimaginably stiff or rigid.
Way more rigid than steel.
Right, to support those high-frequency waves.
Yeah.
But at the exact same time, the Earth and all the planets are orbiting through this exact same medium.
So if the ether is that rigid,
why doesn't it create friction? Why hasn't the Earth been slowed down by this ether drag and just crashed into the sun millions of years ago?
it's a massive contradiction. The physicists were essentially forced to invent a substance that was infinitely rigid, yet completely frictionless.
Which makes no sense.
None. But they were so desperate to save the wave mechanics of light that they mapped out the entire cosmos with this invisible substance anyway, which brings us to 1887.
Oh, this is the climax of the classical ether theory.
The Michelson-Morley experiment.
This is one of my absolute favorite moments in the history of science. Albert Michelson and Edward Morley set out to detect this ether wind.
The logic was pretty straightforward, actually.
Yeah, if the universe is filled with this stationary ether and the Earth is hurtling through space at thousands of miles an hour, we should feel an ether wind. Just like you feel wind on your face when you ride a bicycle on a still day.
Right.
So they built this incredibly sophisticated device called an interferometer.
And the brilliance of the interferometer really cannot be overstated. What they did was they took a beam of light, split it in two, and sent those two beams bouncing back and forth along perpendicular paths.
So one is moving parallel to the Earth's movement, and one is at a right angle to it.
Exactly. Then they recombined the beams. The idea was that if the Earth was moving through an ether wind, the light beam swimming against the current should take a tiny fraction of a second longer to return than the other beam.
It's like swimming upstream versus swimming across the river.
Precisely. And when the beams recombined, this tiny delay would create a measurable interference pattern, or a fringe shift.
And they went to insane lengths to make sure this was accurate. They isolated this device on a massive block of sandstone.
They floated the whole thing in a pool of liquid mercury.
Yes. To eliminate any vibrations from the street or the building or anything, they spun it around, taking measurements at different times of day, at different times of the year, perfectly accounting for the Earth's rotation and orbit.
They did everything right.
They ran this flawless experiment, looked through the eyepiece, and nothing.
A complete, spectacular null result.
The speed of light was exactly the same in every single direction. There was no ether wind at all.
The Michelson-Morley experiment is arguably the most important failed experiment in the history of human thought. That null result sent shockwaves through the scientific community.
It must have been terrifying for them.
It created an absolute crisis. I mean, for nearly 2 decades, brilliant minds like Hendrik Lorentz and George Fitzgerald tried to invent mathematical workarounds to save the ether.
They were trying to explain away the failure.
Yeah, they proposed that maybe the experimental apparatus itself was physically contracting as it moved through the ether, which perfectly masked the result.
They were clinging to the ether for dear life. They were willing to say that solid physical objects squished into form before they were willing to admit that space is actually empty.
It shows how deep that intuition ran.
But then, in 1905, a guy named Albert Einstein steps in.
With his theory of special relativity.
Right. And Einstein does something incredibly elegant here.
Yeah.
He essentially says, stop trying to save the medium.
He just cuts the Gordian knot.
He postulated that the speed of light is constant for all observers, regardless of their motion. He threw out the idea of an absolute reference frame entirely. And in doing so, he proved that light doesn't actually need a physical medium to travel through.
The classical mechanical ether was officially dead.
Dead and buried. Which leaves us with a profound, lingering question. Special relativity dismantled the 19th century ether. But does that mean the empty space around you right now is actually empty? Is the void truly a void?
With the classical ether gone, you'd think the answer is yes. Space is just this dead, silent stage where particles occasionally bump into each other.
But science didn't stop in 1905.
Far from it. Modern physics stepped up to answer that exact question, and the answer is a resounding no. Space is absolutely not empty.
Not even close.
To understand why, we have to look at quantum field theory, which emerged in the decades following Einstein's work. Quantum field theory fundamentally rewrote our understanding of reality. It replaced the concept of an empty void with a universe composed entirely of dynamic interacting fields.
Let's define exactly what we mean by a field here, because it can sound a bit abstract for people who aren't quantum physicists.
Good idea.
Instead of thinking of the universe as a massive empty room where tiny solid billiard balls, particles are bouncing around, quantum field theory asks us to imagine the universe as an infinite series of invisible overlapping oceans.
Oceans of fields.
Exactly. You have an ocean for electrons, you have an ocean for photons, and these fields exist absolutely everywhere in the universe. What we call a particle is just a localized wave, like a little excitation or a ripple in that specific ocean.
What's fascinating here is the implication this has for empty space. If we take a region of space, completely seal it off, pump out every single atom, block all the radiation, and drop the temperature down to absolute zero.
We have what classical physics would call a perfect vacuum.
Right. But in quantum field theory, those underlying fields don't just disappear, they are still there. And due to the laws of quantum mechanics, specifically Heisenberg's uncertainty principle, a field can never sit perfectly still with exactly zero energy.
It's physically impossible for the quantum motion to be perfectly flat.
Exactly. There is always a baseline level of activity, which is known as zero-point energy.
So even in a perfect vacuum, these fields are constantly bubbling.
Spontaneously.
Yeah, virtual particles are spontaneously popping into existence, borrowing energy from the vacuum for just a fraction of a millisecond, and then annihilating each other. So the vacuum isn't a void at all. It is a highly structured, violently active, boiling sea of quantum fluctuations.
And this isn't just theoretical math on a chalkboard either. We can actually measure the physical force of this vacuum energy.
The Casimir effect.
The Casimir effect is a perfect example. If you place two uncharged, highly polished metal plates incredibly close together in a vacuum, the quantum fluctuations outside the plates will actually exert a greater pressure than the microscopic space between them.
And it pushes the plates together.
It pushes them together. We can measure the universe's seemingly empty space physically pushing objects.
That is just wild to me. But wait, if space is full of these constantly fluctuating quantum fields, why don't we feel immense drag? Why doesn't the Earth crash into the sun, which is exactly what the 19th century physicists were terrified of with their space jelly ether?
It's a really important question, and it highlights the genius of modern physics. The quantum vacuum is what we call Lorentz invariant.
Meaning?
Because it lacks an absolute state of rest, no matter how fast you're moving through it, the vacuum looks exactly the same to you. It doesn't resist uniform motion. It provides the structure of reality without imposing friction.
So it's definitely not the luminiferous ether of the 1800s.
No, the mechanics are entirely different.
But when you step back and look at what quantum field theory actually describes, a universe where continuous fields exist everywhere, where energy fluctuations occur even in the darkest vacuum, and where space itself possesses measurable physical properties, it provides an incredible mathematical validation of the ancients' core intuition.
It is a profound testament to the accuracy of human intuition. The ancient models, the Greek scaffolding for the stars, the vibrational medium of akasha, the connective flow of chi, they were absolutely incomplete.
And mechanically flawed.
Definitely flawed. But their underlying feeling that space is an active, structured thing,
Yeah.
that was astonishingly accurate. We felt the fundamental structure of the universe millennia before we had the mathematics to actually prove it.
And I think because of this deep resonance, the word ether just stubbornly refuses to die out completely.
It really does.
I mean, if you go to a university physics department today and talk about ether, they'll assume you're taking a class on the history of science. They don't use the word in the lab. But outside the laboratory, in our broader culture, the concept is very much alive.
It survives in philosophy, it survives in metaphysics, and it survives in art.
Why do you think that is?
It survives because it carries a symbolic weight that transcends mathematical equations. Sometimes ether is used poetically to refer to the invisible background of existence. When a contemporary artist or a philosopher uses the word today, they aren't trying to challenge the standard model of particle physics.
Right.
They're trying to articulate the lived experience of being in a universe that just feels deeply interconnected.
It symbolizes the field of connection between things.
Yeah.
When you feel a profound sense of connection to someone on the other side of the world, or you experience a moment of sheer awe staring at a dense forest or a turbulent ocean, ether becomes this linguistic shorthand for that invisible tissue tying it all together.
It's a powerful metaphor.
It represents our lingering, unshakable human sense that reality has deeper, more profound layers beyond what we can immediately touch and see.
Exactly. And whether we are interpreting this concept scientifically through the rigorous lens of quantum fields, or philosophically through concepts like akasha, or even symbolically through art and poetry, the survival of this idea leads us to a really beautiful conclusion.
Which is?
The concept of the subtle medium represents humanity's relentless attempt to understand something deeply profound, that what we observe on the surface is not the whole of what exists. There is always more.
So what does this all mean for you listening right now? We've gone on an incredible historical and intellectual journey together today.
We covered a lot of ground.
We did. We started with the ancient Greeks looking up at the night sky, realizing that the perfect motion of the stars required an invisible, frictionless scaffolding. We traveled to Eastern philosophies to understand akasha as the bedrock of vibration and chi as the continuous vital flow of reality.
Then we hit the 19th century.
Right, where physicists desperately tried to turn this philosophy into a literal mechanical space jelly to carry light waves.
We felt the sheer intellectual whiplash of the 1887 Michelson-Morley experiment, where the ether was seemingly disproved forever, forcing Einstein to rewrite the laws of space and time with relativity.
And finally, we arrived at the dynamic, bubbling, energy-filled vacuum of modern quantum field theory, where we learned that the void is actually a symphony of underlying fields.
Through it all, over thousands of years and across countless paradigm shifts, the intuition held strong.
Space is a substance. Space is active.
This brings us to a final, provocative thought, something for you to mull over after this deep dive is finished.
Lay it on us.
Modern quantum physics insists that fields exist absolutely everywhere, and that even the deepest vacuums are teeming with potential energy. At the same time, the ancient concept of the subtle medium philosophically symbolizes the unbroken connection between all things.
Right.
So, if the space separating you from the screen in front of you, or the space stretching between you and the furthest galaxies, is not a dead, empty void, but an active, structured physical field, does that mean there is literally no empty space separating you from the rest of the universe?
Wow.
If the space between us is a physical, vibrating structure, are we, in a very real, tangible sense, physically touching the stars?
I love that. Next time you look up at the night sky, or even just look across the room, remember that you're sitting inside a vibrant, dynamic, unseen ocean of energy. Thank you so much for joining us on this deep dive. Keep asking questions, keep looking for those invisible connections in your own world, and we'll catch you next time.